Hi everyone, welcome to our channel, The Two Data Detectives. I'm Nirandi and today we are going to share our thoughts about MemGPT or Memory GPT. This is a paper that came out of a research group in UC Berkeley, and this paper talks about how LLMs can be used as an operating system when analyzing large documents or when having multi-session chat conversations. The reason why I found this paper to be useful is because of an interesting problem we come across every day when I work with clients. One of the requests from our clients is if they were to add a LLM to their enterprise chatbot, they want the LLM to reply to their customer queries based on their organization's information repositories, not generic answers. When a customer asks me to develop a system like that, what I do is I generate a system prompt and then find a way to retrieve relevant context for a user query, append it to the system prompt, and append the user query and send it to the LLM. But more often than not, when I design the system like this, I hit the LLM's context length limitation. For example, if I'm using Llama 2, then the limit would be 4096 tokens. And that has been a very annoying problem for me.
Sounds like the RAG pattern can solve this.
Yes, that's a very interesting observation, Sherry. Our go-to solution for this problem is the RAG pattern, right? However, we are still limited to the context length of a LLM, right? But what customers really want is they have large documents and long conversations with their customers. They want the LLM to use this information as much as possible without being limited to the context width of a LLM. In other words, they need a LLM to have infinite context width and generate a relevant
That's
response.
true.
And if you try to naively extend the context length of transformers, that'll incur a quadratic increase in computational time and memory cost because of the transformers architecture. And this is where MemGPT presents a very interesting idea. What MemGPT is saying is, yes, LLMs have finite context width, but we have this really cool strategy based on memory hierarchies for LLMs, very similar to how an operating system manages its limited memory. So based on this LLM memory hierarchy, MemGPT has the ability to give the illusion that LLMs have a context width that is infinite. And they call it virtual context management, which is cool.
The large
right?
language model is like a computer.
Yes, correct. What they're saying is, let's look at this large language model called MemGPT and think of it as an operating system that's able to identify what contexts are relevant and important to the current user conversation right now, and have an automatic mechanism in there to figure out which context text needs to be replaced, which needs to be written into memory, and how frequently, and do we need to do iterative summarizations to stay within the token limit. So as a result, the context you pass to generate the next response is up to date and it's growing and it's not losing any important information.
So it's a whole different scheme.
Exactly. Similar to how we have context switching, context management and paging in operating systems, in MemGPT, you have virtual context management. And as you said, Sherry, it's very similar to the CPU processor we have in our computers. So instead of a CPU, what we have is a LLM process.
That's so interesting.
In our next session, we'll have a look at the MemGPT code and play with it. Thank you very much.